Gradient boosting in machine learning. AI intermediate level. Introduction. Machine learning models sometimes struggle to achieve high accuracy when using a single algorithm. To improve performance, machine learning uses a technique called ensemble learning, where multiple models work together to produce better predictions. One powerful ensemble method is gradient boosting. Gradient boosting builds models sequentially, where each new model corrects the errors made by previous models. This technique is widely used in many high-performing machine learning systems such as recommendation engines, credit risk prediction, fraud detection, ranking systems, Kaggle competition models. Understanding gradient boosting helps learners understand how multiple models can work together to improve prediction accuracy. What is gradient boosting? Gradient boosting is a machine learning technique that builds a strong model by combining many weak models, usually decision trees. Each new model focuses on correcting the errors made by the previous model. In simple words, gradient boosting equals improving predictions by sequentially fixing previous errors. Example concept. Weak model means error means next model fixes error means strong model. This process gradually improves prediction accuracy. Idea behind boosting. Boosting is an ensemble learning method where models are trained one after another. Each model tries to correct the mistakes of the previous model. Example concept. Model 1 means Model 2 means Model 3 means improved prediction. Instead of building independent models, boosting builds dependent models that learn from previous errors. How gradient boosting works. Gradient boosting follows a step-by-step process. Example concept. Step 1. Train first model. Step 2. Calculate prediction errors. Step 3. Train new model to correct errors. Step 4. Combine models. The final prediction is the sum of predictions from all models. This iterative learning process helps reduce errors. Weak learners. Gradient boosting typically uses decision trees as weak learners. Weak learners are simple models that perform slightly better than random guessing. Example concept. Simple trees means combined means powerful model. By combining many weak learners, gradient boosting builds a strong predictive model. Gradient concept. The term gradient comes from optimization. Gradient boosting uses gradient descent techniques to minimize prediction errors. Example concept. Prediction error means gradient calculation means model improvement. The algorithm moves in the direction that reduces the loss function. This allows the model to learn gradually. Loss function in gradient boosting. Gradient boosting minimizes a loss function. A loss function measures how far predictions are from actual values. Common loss functions include mean squared error for regression, log loss for classification. Example concept. Predicted value minus actual value means loss. The algorithm tries to reduce this loss with each iteration. Gradient boosting workflow. A simplified workflow looks like this. Train initial model. Down pointing arrow. Calculate residual errors. Down pointing arrow. Train new model to predict errors. Down pointing arrow. Add model to ensemble. Down pointing arrow. Repeat until performance improves. This process continues until the model reaches optimal performance. Popular gradient boosting algorithms. Several popular machine learning libraries implement gradient boosting. Examples include XGBoost, one of the most powerful gradient boosting algorithms, known for speed, high performance, regularization support. LightGBM, designed for faster training on large datasets. XGBoost, handles categorical data efficiently. Example concept. Gradient boosting means improved libraries means better performance. These tools are widely used in real-world AI systems. Advantages of gradient boosting. Gradient boosting offers several benefits. Advantages include high prediction accuracy, ability to handle complex patterns, works well with structured data, flexible loss functions, strong performance in competitions. Example concept: sequential learning means improved predictions. Because of its accuracy, gradient boosting is widely used in industry. Limitations of gradient boosting: despite its power, gradient boosting has some drawbacks. Limitations include slower training compared to simpler models, sensitive to hyperparameters, can overfit if not tuned properly. Example concept: too many trees means overfitting risk. Proper tuning and regularization help control these issues. Example Python code. Example using scikit-learn gradient boosting. Import the algorithm from sklearn. Ensemble import gradient boosting classifier. Train the model. Model equals gradient boosting classifier. Model.fit x_train y_train. Make predictions. Predictions equals model. Predict x_test. These commands allow developers to train gradient boosting models easily. Real-world applications. Gradient boosting is widely used in real-world AI systems, finance, credit risk prediction and fraud detection, e-commerce, product recommendation systems, marketing, customer behavior prediction, search engines, ranking search results, healthcare, disease prediction models. Concepts learned from gradient boosting. Understanding gradient boosting helps learners understand. Checkmark how ensemble learning improves model accuracy. Checkmark how weak learners combine into strong models. Checkmark how errors are corrected sequentially. Checkmark how loss functions guide model improvement. Checkmark how gradient optimization improves predictions. Gradient boosting is one of the most powerful algorithms in intermediate machine learning. Simple definition: gradient boosting, an ensemble machine learning technique that builds models sequentially, where each new model corrects the errors made by previous models. Final summary: gradient boosting is a powerful ensemble learning technique used to improve machine learning model performance. It works by combining multiple weak learners, usually decision trees, and training them sequentially to reduce prediction errors. Using gradient-based optimization, each new model focuses on correcting previous mistakes, resulting in a highly accurate predictive system. Because of its strong performance, gradient boosting is widely used in industries such as finance, healthcare, marketing, and e-commerce. Understanding gradient boosting is an important step toward mastering intermediate machine learning algorithms and ensemble methods.